Imagine peering into the depths of the universe and uncovering secrets that turn everything we know on its head. Brian Cox is about to take us on that journey with James Webb's latest discovery. What if the Big Bang isn't what we thought it was? Space lovers, get ready for a mystery that will rocket your imagination to new galaxies. The last dying star will gradually cool and disappear. Without it, the cosmos would return to its original state, dark and meaningless. This is what Brian Cox, a physicist, cautioned. When the last star goes out, it will mark the beginning of an eternal night. Monster black holes will eventually devour all matter, causing the black holes themselves to dissipate into the faintest traces of light. As the universe continues to expand, even that faint light will become too dispersed for interaction. Eventually, everything will stop. Strangely, some cosmologists think our own Big Bang may have originated in a cold, dark, empty universe, similar to the one that awaits us in the distant future. But before we get there, let's examine the origins of material, actual substance. There was no observable atomic or molecular stuff at the time of the Big Bang, and for hundreds of thousands of years following, if that is what we are trying to explain. Once conditions cooled down enough for complex stuff to be stable, atoms formed from smaller particles, and we now know that these atoms were merged into heavier elements inside stars. However, this comprehension does not answer the query of whether or not something arose from nothing. So let's go back in time a bit. Protons and neutrons, which are found in every atom's nucleus, were the first ever stable matter particles. About a 10,000th of a second after the Big Bang, they began to form. Before that time, there was essentially nothing that could be considered material in the conventional sense. However, physics allows us to continue retracting history, all the way back to physical events that occurred before the existence of stable matter. The so-called Grand Unified Epoch is reached at this point. Since our experiments currently cannot provide enough energy to examine the kind of processes that were going on at the time, we have moved well into the area of speculative physics. However, it is possible that the universe was constructed from a mix of elementary particles with short lifetimes, such as quarks, which are used to construct protons and neutrons. There was an approximately equal amount of matter and antimatter. Each type of matter particle, such the quark, has a mirror image companion made of antimatter, which is nearly identical to itself, but for one small detail. The constant creation and destruction of these particles is explained by the fact that matter and antimatter are instantly destroyed when they collide. But the question remains, where did these particles come from? According to quantum field theory, there is even physical activity in a vacuum, which is intended to correspond to empty spacetime. In the form of energy fluctuations, particles can emerge temporarily due to these fluctuations and then vanish again. Although the existence of such particles may seem more like a mathematical oddity than a fact of nature, they have been observed in numerous investigations. Particles are continually being generated and destroyed out of nothing in the space-time vacuum state. That the quantum vacuum is something rather than nothing may be all we can conclude from this. Accounts of the Big Bang that claim to get something from nothing in this way have been sharply criticized by philosopher David Albert. Let's pretend we want to know. Where did space-time come from? Then we can keep rewinding deeper into the genuinely distant Planck epoch, a time in the universe's history so early that our most advanced physics theories fail. 1/10,000,000th of a trillionth of a second after the Big Bang, this era began. Quantum fluctuations could now affect space and time themselves. Typically, physicists divide their time between quantum mechanics, which governs the subatomic world, and general relativity, which is relevant at the galactic scale. However, a full theory of quantum gravity that unifies the two is required to gain a thorough comprehension of the Planck period. However, there have been attempts to develop a comprehensive theory of quantum gravity, such as string theory and loop quantum gravity. Normal spatial and temporal concepts are considered as emergent in these attempts, much like ocean waves. What we see as space and time is actually the result of quantum events at a more fundamental, microscopic level. Processes universes that make little sense to us as macroscopic organisms. Because our regular conceptions of space and time break down in the Planck epoch, we can no longer rely on our regular conceptions of what causes what. Despite this, all competing quantum gravity theories postulate a quantum antecedent to standard space and time that existed during the Planck period. One component of the Planck epoch world may be explained in terms of another, even though causality no longer applies in any regular sense. Unfortunately, by this point, not even our best physics can provide any solutions. Until we make further headway toward a theory of everything, we won't have a conclusive answer. As far as we know, there have been no confirmed cases of something coming from nothing in the realm of physics. Explaining the quantum state of the entire cosmos at the start of the Planck period is necessary if we are to provide a satisfying answer to the issue of how something could come from nothing. Every effort to achieve this goal so far has been purely theoretical. For some of them, the supernatural plays the role of a designer. However, there are still physical possibilities for an explanation, such as an endless number of parallel universes, or the multiverse, or a cyclical model of the universe's birth and rebirth. A model for a cyclical cosmos called conformal cyclic cosmology has been presented by Roger Penrose, who is a leading candidate to win the Nobel Prize in Physics in 2020. Penrose was motivated by a fascinating mathematical connection between the universe's extremes of temperature and density, as it was during the Big Bang and as it will be in the far future when it was expanded into a cold, empty, contracted state. His unorthodox explanation for this correspondence is that, when pushed to extremes, the two states become mathematically equivalent. It's possible that the universe's stuff originated in nothing at all, which sounds counterintuitive. Three main hypotheses might be advanced. There might be nothing physical that can explain it. Alternately, there could be an infinite number of cycles, each of which is its own universe, with the quantum state of the universe at its inception being described by some aspect of the universe before it. Alternatively, the beginning of the cycle could be explained by some aspect of its conclusion, leading to a universe with only one cycle. The unique allure of the latter two methods lies in their elimination of the necessity for random occurrences. There would be no mysteries that physics couldn't solve. Basically, if something has a chance of happening that is greater than zero, it happens in some quantum alternative world. People just like you live in other worlds, and some of them have won the lottery, been swept up into the air by a freak typhoon, caught fire on their own, or done all three at the same time. Some people think that we might be able to see imprints of these parallel worlds in cosmological data, where they were made when another universe crashed into ours. Conformal circular cosmology gets a new twist from many worlds quantum theory, but Penrose doesn't agree with it. Our Big Bang could be the rebirth of a single quantum multiverse with an endless number of universes happening at the same time. Everything that could happen does happen, and then it happens over and over and over again. So that's all for today, Space Maniacs. We hope you liked the video. If yes, don't forget to hit that bell icon for more interesting videos. Till then, explore this universe.